You will remember from when we were looking at network hardware, we talked about bridge and gateway devices. A bridge is used to link networks using the same protocols, and a gateway is used to link networks of different protocols. The key word here is protocols. So what are protocols? Protocols can be seen as rules or engagements between two communicating networks. We use protocols all the time. In school, both teachers and pupils have a code of conduct, which is a set of rules on how to behave. In marketplaces, there are agreements or protocols on how to conduct business, such as using the same currency, the same weights and measures, and where the shop is located in the market area. Even in conversation, you could say we use protocols, not only in how we greet each other with a handshake, but the language we use in order to communicate. Networks use lots of protocols in order for communication to occur. In Year 11, you looked at quite a few. These being FTP, SMTP, HTTP, HTTPS and WAP. In Year 12 you will look at TCP, IP and Ethernet. All of these protocols contain rules on how a specific process needs to be done in order for communication to occur between networks. Let's spend a few minutes reminding ourselves about the purpose of these protocols you looked at last year. File Transfer Protocol, FTP, is used to send and receive files from other computers over the Internet. It works by the client asking for a file from the server, and this file being sent back to that client in a compressed format. In order for this file to be requested and sent, there are two connections. One is for the transferring of the file. The second connection is the control connection, which controls the rate of information transfer. Small Mail Transfer Protocol, SMTP, is used for the transferring of email messages from source to destination email server. It works by the email message being broken up into packages, each with the destination attached to each package. The client's email server looks at the destination address and sends the message to the destination server, ready for the recipient to log in and read their email. Hypertext Transfer Protocol, HTTP, transfers data such as hypertext, audio and video between client and server. It works like the SMTP protocol, but these messages are only read by computers, like the browser, and these messages are not stored but read immediately. The S in HTTPS means secure. This protocol ensures that there is safe and secure interactions occurring on the Internet. We can see HTTPS on websites when we see HTTPS before the web address, or there is a padlock icon showing, or that the text in the web browser turns green. The protocol uses public and private keys to enable encryption. We will look at public and private keys and the use of encryption in a later video. The last protocol we looked at last year was Wireless Application Protocol, WAP, which is used to put web pages on mobile devices. This protocol is able to put a less complicated website on mobile devices as they have a smaller screen size. The WAP protocol can do this by rewriting the web page code into a more simplified language. Each of these protocols and others will come into play or be activated at different stages of the communication process. So some protocols will be used to create the message, others to transport that message, others to ensure that the message remains secure. And some protocols are used again at the receiving end to put the message back together without any mistakes, so the user or computer can understand the sent message. To make it clear when and which protocol is used, a structure is needed. In your course, that structure is called the Department of Defense model. This model allows us to do the following. It allows programmers to see how protocols are able to work with each other if they are on the same level, as well as see how protocols can interact with each other when on different levels. This model ensures that all the different types of network devices that connect to a network are able to talk to each other in the same way. It allows programmers to develop protocols for specific levels, as well as provide a common vocabulary of protocol names and definitions which programmers can work with. As you can see from this Department of Defense diagram, it has 4 stages, and each one with a specific role and can contain a number of protocols. The application layer connects the user to the computer. Depending on what application the user uses, such as an email or web browser, will determine what type of message is sent. The transport layer, also called host-to-host, has 3 functions. It is used to create the connection between the sender and receiver. It provides tools to turn the address in the URL www.stevenschool.wa.edu.au into the numeric IP address used, such as 129.79.78.8. And it is responsible for breaking a message into smaller packets before the message is sent. And at the destination end, it will then check the data integrity and place these packets back in the correct order before the message is read. The Internet layer is responsible for addressing and routing of packets. It determines where the next computer message should be sent to so that it can follow the best route through the network. Here you can see the adding of extra information to the message, which is the user data. As the message moves through the Department of Defense model, this process of adding information is called encapsulation. The network layer, also called the link layer, is the physical layer and is concerned with how the data is to be physically carried between computers and networks over various transmission media, such as fiber optics, copper wire, and wireless. This layer will also check that the route itself is free from transmission errors, and will also create boundaries of where a message starts and ends. Finally, let's look at how a message moves from one computer to another over various transmission media, using both IP and MAC addressing. You may remember that a MAC address, short for Medium Access Control, is a unique identifier used to identify every device on a computer network. You could see the MAC address as your name. The name you have is not going to change throughout your lifetime. The IP, or Internet Protocol address, identifies the network the computer is in. You can see the IP address as where you live. This could be more temporary. Unlike your name, which will not change, where you live over the course of your life certainly can. Let's say you write an email. This email message, after going through the application, internet, and transport layer, comes to the network layer. On its journey through the layers, encapsulation has taken place to this message, with lots of additional information having been added, such as the MAC source and MAC destination addresses. The message and additional information has been broken up and is placed into lots of data packages, something similar to an envelope. This envelope has then been stamped with the destination IP address. This data package, or envelope as we're calling it, comes to the network interface card, which puts each envelope into another container called a frame. As this email travels across the internet, it may be transported via cable, fiber optic, or wirelessly. Every time a data package comes to a different transport medium, the data package is taken out of its old frame and placed into a different frame for that particular transport medium. The data package itself stays intact, as it does not matter how many different frames it goes through. Once the data packages reach the receiving network, the frames come to the receiving server. The server's NIC card will extract the contents from the MAC frame and gives that data package to the IP software. The IP software takes the message out of the data package, looks at the MAC address on the data package, and the message is sent to that specific computer. Also, on the data package is information saying what application should open up the message. That concludes our talk on protocols. Thank you for listening. Bye-bye.